Hello students, welcome to the physics concept, and today we are going to learn a very important topic, that is series LCR circuit. If you look at the question, using phasor diagram derive an expression for the impedance of a series LCR circuit. What is impedance? We will come to know as we go ahead with our topic. So if you look at the diagram, in this diagram, resistance, inductor and capacitor, these are connected in series. That's why it is given series LCR circuit. L means inductor, C means capacitor, and R means resistance. So these three are connected in series. Or do circuit te AC source ekta connect korne ase, AC source. Okay, so itu voltage, AC voltage connect di ne ase ma supply korne ase re. To ere saisule do itu AC voltage per current supply kro do circuit te kita current do across the resistance, across the inductor and across the capacitor flow going jawo, that is voltage te drop ho, voltage te loss ho. Okay, all voltage they drop ho. To kiman voltage they drop ho across the resistance kulido, according to Ohm's law man find out ko paro. Voltage they drop ho do across the resistance to I into R ho. Across the inductor voltage drop out ho do I XL ho, or across the capacitor do I XC ho. Okay, so iman voltage drop out ho across resistance, inductor and capacitor. Man already porishe resistance zero, voltage or current, they are in the same phase. In the same phase in case of resistance though. Resistance state ala phase difference to 0 ase. Okay, since they are in the same phase, so if you look at the difference between this voltage and current, the phase difference between voltage and current is 0. Whereas in inductor, the phase difference between voltage and current is 90 degree. So if you look at the inductor, voltage leads the current by pi by 2. Pi by 2 means 90 degree. Okay, pi is equal, 1 pi is equal to 180 degree. So 180 divided by 2 is 90 degree. So if you look at the inductor, in inductor, voltage leads the current by 90 degree. And if you look at the capacitor, in capacitor, current leads the voltage by phase angle 90 degree, that is pi by 2. Okay, see, there is one tricks which we can easily remember. Using this one, if you look at the, see, in inductor, as we all know, in resistance, voltage and current, they are in the same phase. Okay, so the phase difference between voltage and current in resistance is 0. Whereas in inductor, if you look at the inductor, you see, itu last itu inductor ede sunna itu ede sabide itu last in the word te sabide VIL. So this is inductor, right? So here voltage comes first, then current. So in inductor, voltage leads the current by phase angle pi by 2, that is 90 degree. Whereas if you look at the capacitor, then you see the first three word, okay, first three letter, here's capacitor, and after that I comes, right? So here in capacitor, current to voltage per lead korine ase kiman bra 90 degree. So it's very easy to remember if we remember these tricks. Okay, see, itu tinta sabido. In case of inductor, itu L ase, aro itu voltage or current ase, right? So in case of inductor, voltage first ahe, current second ahe. To inductor dedo voltage lead kori ase. Okay, or capacitor saisule do yete sabi, itu capacitor yete ase, itu biside current first ahe, itu biside voltage ahe. So in case of capacitor, current lead kore, aro voltage to lag kore. Okay, kiman bra 90 degree. Okay, so please remember this. It will help you to remember who leads and who lags. Okay, so तो यदि मान की कोई using phasor diagram derive an expression for impedance कोई तो यदि मान first phasor diagram बनाओ try करो okay and then मान impedance ला expression show करो तो phasor diagram सही शुले दो since itu ला LCR ला phasor diagram बनाओ तो मान ना तो in case of resistance सही शुले दो voltage और current तो तान same phase ते ही ऐसे तो same phase ते उले दो मैं ना बनाई दो that voltage और current दो same phase ते आसे जब मैं same line दे ही voltage भी दिवो current भी दिवो it means that they are in the same phase okay और तो जिनला phase difference तो zero आसे clear और ये दे सही in case of inductor दे सही तो inductor दे तो voltage पर lead करे current के तो मैं ना करो ये दे current आसे तो मैं voltage के ना बनाई दो मैं voltage के ना बनाई दो okay सही it voltage this voltage is ahead of this current right current तो पीछे दाई जिसे तो अब voltage तो ahead of current ना तो voltage leads the current by how much angle pi by 2 that is 90 degree तो मैं ये ना दी दो voltage leads the current by pi by 2 okay whereas in case of capacitor saishule do current leads the capacitor by pi by 2 that means current lead kore asu do capacitor ge to mo capacitor ge yede show kodo ina show kodo that means here kiman bra current lead kore ase pi by 2 to pi by 2 yede do to sabi current is ahead current to age de ase voltage piche de ase to na capacitor la voltage to piche de ase aru current to age de ase that means current leads the voltage by pi by 2 okay to yedi ki show korle sule to moi sabi itu to apply voltage asu do aru itu to voltage across resistance voltage across inductor aru itu voltage across capacitor asu do that means sum of this plus this is equal to applied voltage ho do na kile itu to supply kore asu mana itu pra hi voltage drop out hoye ase across resistance across inductor and across capacitor na itu tinda la sum kuri chule do tai la equivalent ho do na to ma itu phasor diagram de man show kuro that sum of voltage across resistance across inductor and across capacitor is equal to the applied voltage ina show kuro man phasor de to man kina show kuro bole to sabi itu voltage across inductor voltage across capacitor and voltage across resistance to itu ke sum up kuro 8 kuro to ede kina 8 kuro bole to man vectors la rules kumba apply kuro okay to ede sai shule to itu vl to pode ase aro vc do ina niche re ase voltage across inductor and voltage across capacitor ro niche re ase to moi ede consider kuro re that voltage across inductor is greater than voltage across capacitor moi ede to consider kore ase okay I'll just write down somewhere here let voltage across inductor is greater than voltage across capacitor okay that means inductor la voltage to capacitor la voltage pra bcs na consider kuri ase to ina huishule do man ke na ede vector rules apply ko paro kule to sabi ido voltage across inductor kore ase voltage across capacitor do niche ase aru voltage across inductor do tera bishi wala su do to tajun ke vector addition rule apply kuro ma to vector addition rule ede use kuri to kina kuro gole do sabi itu vl bc asu do vc wa na to moi ede na ko do vl plus minus vc kile moi minus dc gole do vl or vc do they are in the opposite direction so if one become positive then other becomes negative since vl is greater than vc so I am considering that voltage across inductor is greater than voltage across capacitor na to jone moi tu ke voltage across inductor ke plus dise aru moi tu ke minus consider korche to ina hole do voltage across inductor minus voltage across capacitor ina pai jaw do moi na to ina korishule do itu bra itu ke minus korishule do man ta jun la addition to itu pau de ta jun addition do VL minus VC. That means the last addition result do itu pawo de. Kile VL de man olop itu minus kuri hatai disu do. Itu jai jawo do na. Itu pawo do na. Like example itu 7 ase koi voltage across inductor. Itu ro 3 ase koi voltage across capacitor 3 ase. So since they are in the opposite direction, itu 7 to plus hubo gule huishu gule do itu minus hu jawo do minus 3 hobo do. The 7 minus 3 man kiman pai ase 4 pai ase do plus 4 na. That means yadi do ro olop to bachishu do 7 de minus 3 gule lo bachibo do. That means itu 4 do taijunla resultant asun na. Itu nisna kitia voltage across inductor de itu capacitor do man vector rules apply korini add kuro yate result to man VL minus VC itu pau. That means this is the resultant of VL minus VC itu resultant ase. Okay, that means itu or itu do pai jisu man ita na ita do man VR kile man first do V voltage across resistance, voltage across inductor plus voltage across capacitor is equal to itu show korle sudo. Tumo VL plus VR plus VC ke sum up korle sudo. Sum up korni itu show korle sudo na magnitude to itu resultant to show korle sudo. Tholi to mala vectors pra key rules man ke follow korle de itu rules follow koro do. Itu man vector la rules follow kore ase de. Okay. The first VL or the VC de man simplify kurise man paise that itu duta ke simplify korle do VL minus VC pao. Okay, to itu tajunla resultant do itu ase VL minus VC. Okay, itia do itu VL minus VC or to VR ke add kro. Itu ke add kurishule do sabi man ki rules apply kro ede. It man parallelogram law of vector addition rules apply kro. Okay, to itu or itu ke add kurishule do malo pina di do man ede vector diagonal law. Okay, diagonal itu ede vector diagonal lishule do itu diagonal bra itu diagonal do diagonal resultant show kro both in magnitude as well as in direction. Okay, so itu sorry this plus this to itu pai dekse do itu na ita do man itu or itu kurishule itu ola v do pai jawo itu magnitude to na itu besari dekse do man do. Okay, first VL plus VC find out kurise man itu paise. To ita do khali itu bachisu do itu dudala resultant luishule do ekta diagonal law lagi tewa na itu diagonal do itu or itu la magnitude result to show kore. So itu do both in magnitude and direction tala or tala ke represent kro. Okay, clear to itu ase aro itu do ere sabi man ki paise man ki tia voltage across inductor is greater than voltage across capacitor. Yate tala itu voltage to ma itu la voltage to itu LCR circuit la voltage to current bra lead kure ase. That means voltage to current bra bishi ola ase. Kiman bra sukule do man ite di do phi angle wa voltage to current bra bishi ase. Kina paishu le do kita man consider krubo voltage across inductor do voltage across capacitor wa dangor ase man ede resultant pado itu pado itu do current bra bishi hola ase itu paise man kiman bra phi angle hulbi man kita consider krubo that voltage across capacitor is greater than voltage across inductor ena huli do tai ede pau ena pau de ena usuli do current do voltage bra bishi ase ena pau man. Okay, to man edi ki consider korise voltage across inductor is greater than voltage across capacitor kita consider korise yade current bado voltage phi angle wa bishola paise man. Okay, to idu phasor diagram ase LCR circuit la to yade hulbi ki hoti ase using phasor diagram itu phasor diagram pai jisu eta mana tan ko ase using phasor diagram expression ekta dibi go ase ki la kole da impedance la to impedance ki ase kole do total resistance in a circuit. Okay, kile do kita yadiwa current enough flow kuri jawo itu resistance inductor or capacitor itu milai ini itu current ke oppose kore try kore. Okay, rukhai dole try kore to itu ke koi impedance tan super milai ni oppose kores na jane man ko total resistance of the LCR circuit educate impedance ko to tula expression ekta show koribe ase formula impedance la formula banao man okay so mujhe olop rap kodo de so here ये साइज तो मैं की का नाम दी दो ओ दी दो ये की p दी दो मैं की q दी दो ओके सो मैं ये इम्पीडेंस ला एक्सप्रेशन शो करला से तो ये साइज तो ये o p q तक द राइट एंगल ट्रायंगल होइछ ना तो मैं ये की करो बोले तो सभी ये प्राय इमान तक vl minus vc असले तो इतला मैग्नीट्यूड भी सेम हो दो इट भी vl minus vc मान कंसीडर को पारो दो लो ले पारो दो ना बिकॉज़ इतला मैग्नीट्यूड सेम आसे राइट तो इट भी vl minus इटु साइड भी vl minus vc हो जाओ ओके और इट द राइट एंगल ट्रायंगल आसे तो मान इटु बिसावले से मान इतना ना we have to show that voltage across resistance plus voltage across inductor is equal voltage across capacitor is equal to v asudo itu v ke man ase moita show kodo odi biside man impedance la expression bi show koro okay to eta sabi ida moi Pythagoras theorem apply koro de itu bisawole itu na so by Pythagoras theorem in right angle triangle OQP okay OQP OP square is equal to OQ square plus QP square तो OP square की असले तो V square OQ is 80 मान तक तो इधर से voltage across resistance plus QP दो voltage across inductor minus voltage across capacitor और इतो square से इधर के square दी दो ये भी square से इधर के square दी दो okay now okay so मैं इधर square के the other side ले जाओ okay तो इन्हें ले जाले इधर root over जाओ plus root over जाओ okay और मान जाने voltage across resistance तो क्या सकले तो IRO तो ला जगह ते मैं I square R square दी दो plus voltage across inductor क्या सकले तो IXL से तो ये रे IXL दी दो minus voltage across capacitor क्या सकले तो IXC से तो मैं IXC दी दो and then to get root over kodo okay it is actually do sabi I square R square plus idu I ase mudu I ke bahar le lo na I square ho jao XL minus XC the whole square root over okay और ये साइज ले तो इधर I square से इधर भी I square से इधर भी commonly लो पारो मैं तो इना commonly लो now R square plus XL minus XC the whole square and apa jo okay और इधर के मैं बाहर उलाई लो I square के बाहर उलाई ले दो मान I R square plus XL minus XC the whole square itu pajo okay aro yate bra man I is equal to V upon R square plus XL minus XC the whole square na pajo okay तो यदि सभी ये लोग कोडो में जगह है so ये z is equal to R square plus XL minus XC the whole square root over तो ये क्या से तो z तो के मान impedance को impedance तो impedance की text को ले दो इतो total resistance of a LCR circuit okay इतो LCR circuit ला total resistance के मान impedance को तो impedance ला formula क्या से को ले दो R square plus XL minus XC the whole square okay तो इतो मान की इतो show करी हुआ है derive an expression for the impedance को आरो इमान तक इतो show करी हुआ है okay और in case pra tahan aro direction bi show kuribi bole do exam de man direction bi sawle asule do direction bi show kuribi kule do man ena kuri do direction do man idu phi ase na idu resultant magnitude asne to na hoine this plus this to itu asudo to itu tala magnitude ase itula milai le man tu pai na itu ase to itula direction do man show kro that means itu kiman angle de ase gule do phi angle de na itu angle bisaro man okay to ere moi 10 phi lilo 10 phi do ki ase gule itu triangle ra bisaro let's say in right angle triangle OQP okay itu triangle of bisarwo OQP ra 10 phi to ki asile do perpendicular by base okay so perpendicular ki asile do VL minus VC aro base ki asile do voltage across resistance itu ke man enabi do pare VL do ki asile do IXL minus VC do IXC और itu voltage across resistance do IR so yete moi IR do paro yete I common lilo so I'll get XL minus XC upon IR this I and this I get cancel out so we'll get XL minus XC upon R itu direction ke show kore okay itu ase aru man yade ekta puro impedance triangle to impedance triangle do kina bunawo itu impedance la triangle do kina bunawo moi tu apni ke show koro eba screenshot le lebi moi rap ko dole ase to impedance triangle it will be important aside 1 mark question aside na impedance triangle draw koribi bole huini aile na impedance triangle the impedance triangle do kina banao bole do ere sabi itu phi ase moi tu side te R duo itu Z duo और do VL minus VC itu के impedance triangle को है तो जो किना पाइसु ले दो इधर सभी ಇದು formula क्या है Z is equal to R square plus XL minus XC the whole square root over nas ना तो itu triangle was है इधर मुझे suppose Pythagoras theorem apply कुरिसिकुले दो क्ली द राइट एंगल ट्रायंगल आस ना Pythagoras theorem apply कुरिसिकुले दो मैं तो impedance ला same formula पाओ दे तेरे सभी Z square hypotenuse square equal to base square plus perpendicular square the whole square के मुझे साइड लू जाले दो root over sorry मैं impedance ला same formula पाइसे ना तो जो कि कोई impedance triangle it do 1 mark sometimes it is to ask for 1 mark in the exam okay तो आज जो देखिए अपने यहाँ एक डाउट ऐसे बोले तो comment section दे comment करूँगी अपने यहाँ डाउट तो clear को